Hi, in this video I will introduce the NBA analysis project, which is for the course Interactive Data Science. Just to give a little bit background, the sport analytics have been really hot these days in the professional sports field, and we also find that there are rich data for NBA games. So we would like to explore a few questions that we have always been curious about with some publicly available NBA data. The driving question of our analysis is that since the league kept evolving from its establishment, can we present some interesting trends with data? The project mainly contains three parts, which are the dataset overview and assessment, the exploratory analysis, and finally the player role analysis. So let me give you more information about the dataset. We got this dataset from the Kaggle page, and the author of the Kaggle project grabbed data from the basketballreference.com, which is a very famous NBA stats reference site. The dataset contains some aggregated individual stats for each NBA player across the year of from 1950 to 2017, and it has features like the total points, the total assists, which are some basic stats, and it also has some advanced statistics such as the true shooting percentage. Then, to better understand the dataset and also ensure the data quality, we did a data quality assessment with the 4C concepts introduced in this course. In brief, we check the dataset to ensure it is complete and also coherent. We also manually check the correctness of the records by comparing to the official NBA website. Finally, the accountability are also assessed in several different ways. If for more detailed information, just check this page to see the details we did to assess the data quality. Cool, so let's talk about the exploratory analysis. First, are the games becoming more offensive? Many recent rule changes in NBAs are set to encourage offense, and do these changes really result in more offensive games? To answer this question, we plot the league average points per game over years, and we do find a increasing trend starting from 2004, and except the lockout season of 2011. So this increasing trend does agree with the discussion about NBA offensive explosion. And we also plot the average points per game across years for other teams, so feel free to exploit it yourself for more information. Then, are the players playing less than before? So another popular discussion around recently is that some players tend to play shorter in a single game to better protect themselves, which is also called the load management. And to see if we do have such trend, we create a report using the average minutes played by a player in a single game. And in this joy plot, we do find that the distribution of minutes played becomes more and more concentrated. In other words, fewer players are having extremely high playing time, which can be interpreted that the top players are playing fewer to protect themselves physically. Then, are the players really trying to make more three-point goals? It is said that since the introduction of three-point goals, there has been a boom in three-point attempts due to its higher efficiency in obtaining scores. So is there really such a trend? Yes, from the error plot we made, we can see that there is an really obvious and consistent increasing trend of the three-point attempts. And we actually plot these every plots for all the teams and found that this increasing trend are consistent for all the teams. Finally, how has the strength of players evolved in terms of the 4 factors? The 4 factor refers to shooting, turnovers, rebounding, and free throws, and they are said to be some key factors for winning a basketball game. We plot some density plots for each 4 factors, and in the plot, each point represents a player, and the players are grouped by their positions. So we can see an interesting trend of increasing effective field goal percentage, and this can be interpreted as that the players are becoming better and better at shooting. There is also a decreasing trend of the turnover percentage, so in this sense the player also become better at avoiding the turnovers. So for the rebounding factors and the free rate factors, we did not find any trend here, so we just skip that and let's go to the player role analysis. Finally, in 1946, the NBA has changed a lot to become what it is today. The classic 5-position categorization is no longer expressive enough for what the modern NBA players do in today's game. So we are wondering, are there more fine-grained player types in modern NBA, or did the players become more positionless? We propose to address the question using network analysis with similarity network between the players. We also provide some interpretation on why some players are similar in roles. The first step is to construct the similarity matrix. We use the PCA, the principal component analysis, to reduce the dimension and also to reduce the correlation between the features. And then we calculate the similarity matrix with cosine similarity and construct the adjacency matrix with a chosen cutoff similarity as 0.9. We chose that cutoff similarity since we want to keep a high standardization of similarity and also to have a sparse network. To answer our question of role involvement in NBA, we conduct community detection for each year from 1987 to 2007, and also visualize the number of detected communities for each year. And for this plots, we actually cannot find significant trend of increasing number of communities, although we can see to increment in the beginning and in the end. This is likely caused by randomness because there are a lot of single member communities in these detected ones. And to make it more stable, we also plot the count of the large communities which have more than 10 members. And for these large communities, the count is pretty consistent across years. So to further understand the meaning of the detected communities and to find possible ways to improve our clusters, we specifically analyze the results from the 2016 and 17 season. To realize the network, we keep only the large communities with more than 10 members and merge all other in a single community. And as we can see from this plot, there are too many nodes with no edge connection to other nodes, and this results in the single member community in our results. And for the large communities, it actually makes sense to me. For example, the red nodes are actually the key players or the star players in the league. For example, LeBron James, Stephen Curry, the Greek League are all in this community. And there is also room to improve because apparently the Stephen Curry and the Greek League play and influence the game differently. So it will be more informative if they will fall into different communities. Due to the time limitation, we will not describe the other large communities, but you're always welcome to check the website for more details. And finally, here's some discussion about how we can get a better result from the player role analysis. First, we may use ICA instead of PCA to do the dimension reduction, because the data may not be Gaussian actually. And also, we may choose the similarity cutoff more carefully. Finally, we definitely should try more community detection algorithm to see if the algorithm will give us a more meaningful community results. Thank you. That's all of this video.